Bismillahirrahmanirrahim. In this session, we will discuss practical electricity under the subject of IGCSE and O level physics from Hodder's education book written by Tom Duncan and Heather Kennett, published in 2021. And here we have some questions. Now put this into practice. An electric heater has a power rating of 1.5 kilowatt. The rating of electric heater is given as 1.5 kilowatt. If the supply voltage is 240 watt, calculate the current in the heater. So power is given, voltage, supply voltage is given as 240 volt, and current, we have to find the current. So current is equal to P is equal to VI, so I is equal to P upon V. So power is 1.5 kilowatt and this is 240 volt. So 1.5 kilowatt is basically 1500 watt divided by 240 volt. So 1500 divided by 240 gives 6.25 ampere. So the current will flow through this heater is 6.25 ampere. Should a 3 ampere or 13 ampere or 30 ampere fuse be used to protect the heater? Since the current is 6.25, so the next fuse of 13 ampere is sufficient to use. So the 13 ampere fuse should be used in this case. A television has a power rating of 100 watt. If the supply voltage is 240 volt, calculate the current in the television. So the power is 100 watt divided by 240 volt. So the current is equal to 100 divided by 240 is 0.416 ampere. And should a 3 ampere or 13 ampere or fuse should be used to protect the television? Since the current is very low, so 3 ampere is sufficient. Electric cooker has a power rating of 6.4 kilowatt. If the supply voltage is 240 volt, calculate the current in the cooker. The current is equal to power is 6400 watt because this is 6.4 kilowatt. So multiply by 1000, so gives kilowatt in terms into watt divided by this. So we have this 26.66. So this 30 ampere will be used for this electric cooker. A largest number of 100 watt bulbs connected in parallel can safely be run from a 230 volt supply with a 5 ampere fuse is. So this is 230 volt 5 ampere. How many? So we will using it. So 5 ampere. So this is 1150 watts. So 5 ampere into 230 volt is equal to 1150 watts. So we can use 11 bulbs. So 1100 watt is sufficient. So 1100. So 11 bulb, maximum 11 bulb can be glued in this case because the maximum 1150 watt is allowed with 5 ampere. So 11 watt is 11 bulb of 100 watt each is maximum load that can be glued through this fuse. So it's better to take some margin, but theoretically 11 bulb is good. What is the maximum power in kilowatt of an appliance that can be connected safely to a 13 ampere to 30 main socket? So I is equal to 13 ampere and this is voltage is 230 volt. So the power is 2900 watt. So theoretical possibility is 3 kilowatt, but with 10% margin, so we should use it to 2.7 kilowatt. So we should use some margin, 10%, 20% margin. So practically in practical situation we actually take some margins. To what part of an appliance in the earth pin on electric pin plugs attached? So the electric pin on the 3-pin plug is connected to the metal case of the appliance, which is thus joined to the earth by a path of almost zero resistance. So the every 3-pin plug has one phase, one neutral, and one earth. The top one or the most large size plug point is always used as an earth. how can a 2-pin appliance be designed to reduce the risk of a user receiving an electric shock if a fault develops? Appliances should, such as vacuum cleaner, hair dryer, and food mixers, are used double insulated. If it is double insulated, then connection to the supply is by a 2-core insulated cable, no earth wire, and the appliance is enclosed in a non-conducting plastic case. So this way we can avoid electric shocks. A metal attachment that the user might touch are fitted into this case so that they do not make a direct connection with the internal electrical parts such as the motor. There is then no risk of shock should a fault develop. So if it touches to the metal or plastic body, then there is no risk. But here we have two double insulations. So usually double insulation gives this kind of protections if even the equipment is not properly earthed. In the next session we will discuss this exam